Today we're going to talk about section 7.7, finding determinants for a matrix. To begin with, a very important note that every square matrix has a determinant, which means it must have the same number of rows as it does columns. So a 2 by 2 or a 3 by 3. If it was a 2 by 3 or a 3 by 2, it would not be square, so it would not have a determinant. To find the determinant, the notation is going to essentially just be, looks like absolute value, but we have these bars around our matrix name. So that reads as finding the determinant of matrix A. We've already talked about this when we're finding the inverse. So for a 2 by 2, we're simply going to go ahead and cross multiply and then subtract. And so then the determinant for this matrix would end up being negative 38. One of the important things to note is if the determinant is in fact 0, that means that the function has no inverse. So for a 2 by 2, again, we're just going to cross multiply and subtract. If you look at at matrix A over here, for example 2, trying to find the determinant, again, because of our notation, we would again cross multiply. So 0 minus a negative 12, and we would get that positive 12 is the determinant of A. If we apply the same strategy to matrix B, again, we're going to cross multiply. That's going to give us negative 40 minus a negative 14, which becomes plus, which means that the determinant of B is going to end up being negative 26. So for our 2 by 2s, very straightforward. We go ahead and cross multiply and then subtract. However, for our 3 by 3s, it becomes a little more challenging. We have to do a little more work here. To begin with, what we're going to end up doing is we're going to temporarily cross off the first row and first column. So we're going to pretend like we're not looking at these. And we are left with a 2 by 2. So we have 5, 6, 2, 3. And we're going to take the one where our row and column that we crossed off intersected. I'm going to put that on the outside. So we're going to multiply this little 2 by 2 by that one when we're done. We're going to go ahead and cross multiply. So we're basically finding the determinant of this remaining 2 by 2, which means we're going to have a 1 times 15 minus 12, which is going to be a 1 times 3. We're going to be repeating this process 2 more times. So I'm going to go ahead and erase what we had crossed off. And now we're going to go ahead and we're going to cross off the first row and the second column, and we're left with another 2 by 2, which would be 4, 6, 1, and 3. And again, that number where they intersected, we're going to put on the outside, but this time we're going to be subtracting. And again, we're going to go ahead and cross multiply. So I have minus 2 times 12 minus 6, which is going to end up just being minus 2 times 6. And then one more time, we're going to go ahead and cross off a different set. This time we're going to go ahead and cross off the first row, and the third column, and we're left with another 2 by 2. So this would be 4, 5, 1, and 2. And then again, that number where they intersect, we're going to put that on the outside, and this would be a plus. And we're going to go ahead and cross multiply and subtract. So we have plus 3 times 8 minus 5, which would be plus 3 times 3. And when we simplify the whole thing, we get for our final answer 0. Now again, what this means is that this matrix actually does not have an inverse. Okay, let's go ahead and apply our strategy to example number 4. Again, we're trying to find the determinant. So my first step is I'm always going to be crossing off the first column and the first row, and I have the remaining 2 by 2. Where they intersect here, I'm going to put that number on the outside, and then for my 2 by 2, we have 6, 5, negative 3, and negative 1. And then we're going to multiply this 1 by negative 6 minus a negative 15, which ends up being a positive 9. Oops. Okay, then we're going to go ahead and move over. So instead of the first column and the first row, we're going to cross off the second column and the first row. And again, where they intersect, we're going to put that number on the outside. So we've got a 3 on the outside, and then our 2 by 2 is going to be 2, 5, 4, and negative 1. Again, we're going to be cross multiplying and subtracting, but this time we're subtracting that 3 instead of adding it. And then we have a negative 2 minus 20, so that's going to be minus 22. And then for our last operation here, we're going to go ahead and use the third column with our first row. So we're going to cross off our first row and our third column. And we have left over, again, when they intersect, we have a -2. So I'm going to put that -2 on the outside. And we have left over a 2, 6, 4, and -3. And I'm running out of space here a little bit. See if I can move this over. Again, we're going to go ahead and cross multiply and subtract. So we have a -2 times a -6 minus 24, which would be a -30. And then we're going to go ahead and combine all of our values together. All right, so we have 9 plus 66 plus 30, which gets us a total of 135. So the determinants of that matrix is 135. Okay, go ahead and attempt to apply what we just did to the Your Turn B. Hit pause now, and then come back and check when you have your answer. Okay, so I kind of left up all my work here to go through what we did, but again, we cross off our first row and our first column, and we're left with the matrix of 3, 1, 3, 5. When we cross multiply and subtract, we end up getting 12, and then our number where our row and column intersected was 1, so we have 1 times 12. For our second process here, we cross off again first row and our second column. We're left with 2, 1, 4, and 5 for our matrix. Again, we're going to cross multiply and subtract, and we get -2 times 10 minus 4, or -2 times 6. And then finally, we have our first row and our third column. When we cross that off, we're left with 2, 3, 4, and 3. And then we're going to go ahead and cross multiply and subtract, getting us 1 times -6. And when we combine all of our values, we got a final answer of -6. All right, example number 4, it did not exactly show up, but that's okay. We're going to jump into example number 5 here. We're going to talk about how we can use determinants to go ahead and solve for missing information. So let's say that we have the following matrix of 3, 1, x, and 4. And we know that the determinant is equal to 16. That means that the determinant of our matrix is equal to 16. So we can go ahead and apply our general process of finding the determinant to solve for x. We're going to start by cross multiplying and subtracting, which means we get 12 minus x is equal to 16. And then from here, we have an equation that we just used to help us solve for x. I'm going to go ahead and subtract 12 on both sides. We get -x is equal to 4. And then if I end up solving for x here, we get x is equal to -4. If you look at the Your Turn, we'll go ahead and do that one together. Again, we're going to apply the same strategy here. We know that the determinant is equal to 20. And I know it's the determinant because I have these bars, so it's showing me notationally that that is the determinant of our matrix. We're going to go ahead and cross multiply. And if we do, then we're going to get x squared minus a -4. Don't forget we're subtracting that expression is equal to 20, which means this is plus. We're going to go ahead and subtract 4 on both sides, and we get x squared is equal to 16. And then if we take the square root, then we get x is equal to plus or minus 4, which means we actually have 2 possible answers here. All right, one last concept we're going to talk about here is something that is known as a triangular matrix. I'm going to go ahead and draw a matrix. And you notice something kind of unique about this. So let's say I have the matrix -2, 4, 0, 0, -1, 4, 0, 0, -4. The thing that is unique about this is if you look along the diagonal, we have these numbers here. And then below that diagonal, we have nothing but 0. So this is something that we call an upper triangular matrix. And one of the nice things about this is when we're trying to find the determinant of a triangular matrix, whether it's upper or lower, all we have to do is multiply the numbers along the main diagonal. So let's say that this is matrix A. The determinant of A is going to be -2 times -1 times -4, which is going to give me a value of -8. So my determinant is -8. If I make the matrix a little bit bigger, so let's say that I have matrix B, which will be 1, 2, 3, 4, 0, -2, 0, 2, 0, 0, 5, 3, and then 0, 0, 0, -1. Again, this is an upper triangular matrix because all of the numbers above the diagonal are values, but the numbers below are zeros. And because those values below are zeros, we're just going to multiply all of the numbers along a diagonal to find the determinant. So if I wanted to find the determinant of B, it would be 1 times negative 2 times a positive 5 times a negative 1, which would end up being a positive 10. And again, it doesn't matter if the cluster of zeros is below your diagonal or above your diagonal, because these examples have them above. These are upper triangular matrices. If we flipped it and the zeros were above and the numbers were below, then it would be a lower triangular matrix. But if you see that you have a cluster of zeros either above or below your diagonal, then to find your determinant, you just multiply the numbers along that diagonal. All right, that'll do it for our notes for this section. Go ahead and get started on the homework, and good luck.